Hi, welcome to the concept library. Please watch the complete video. So in this video, this is part 4 of the series, uh, graphs to understand static and dynamic stabilities. Okay, so let's see this graph. So in this graph, what is happening? This is a displacement axis and this is time axis. So there is some object and it is being displaced here. So when the actually reality is when the object will displace at certain amplitude or at certain distance displacement, it will take some time, but I am not considering that. I am only considering after being displaced what is happening. So during the displacement, whatever time it is taking, that is not my concern. I am only talking about when this block or when this object got some displacement after being disturbed. After that, what is happening? So you see the displacement axis. After this object is not going for more displacement, or it is not coming back. It is here itself, means it is not taking some time to come back or to go up. Displacement is neither increasing nor decreasing, so there is no tendency to go ahead or come back. So this is statically neutral. Now in this example, I am showing you ball is here and it is being displaced, so it will take some time. So some disturbance happened, because of that this came here, so it took some time. And after that, now what is happening after that? This ball is having tendency to come back. So if this ball is having tendency to come back, so this is statically stable. But after that, what is happening? Then after being statically stable only, we have to discuss dynamically stable, dynamically neutral, or dynamically unstable. So see here what is happening. So if this is a tendency, then definitely we are going to talk about dynamically stable bodies. Now see in this graph what is happening. Statically so this is disturbance, and from here to here statically stable. It is going away and again coming back, going away again coming back. So statically stable but dynamically neutral. Why? So this is statically stable but dynamically neutral. Why dynamically neutral? Why? Because you see finally the ball is not stopping at the mean position. Every time it is achieving the same displacement in both the directions. So these dotted lines are parallel. I am showing like this amplitude, they are equal. You got it? Now let's talk about this graph. See, I displaced the body here, but after that body is not having tendency to come back. Body is going away from the mean position. This is mean position line. So body got disturbed, but still it is being it is going away. See, after this gust is not working. I mean the pressure force, whatever, the disturbing element is not working. Disturbing element was working only from here to here. Once disturbing element is not any, is no more, after that also this ball is having tendency to go, I mean to be, got it? So this is what is statically unstable. So because this is statically unstable, so will not draw graph at all to discuss dynamic stability. Now see in this case what is happening. Ball is here, so ball is going, this is from here to it is disturbance part. After that we have to discuss our nature characteristic. So what is happening? Displacement is decreasing. Okay, very good. So this is dynamically stable. But after that what is happening? Displacement is increasing with time, correct? Displacement decreased from here to disturbance. Then after that it is coming to the mean position. So statically stable. This is statically stable but dynamically unstable. Why? Because it should go like this, but it didn't go in this way. Amplitude is increasing. This amplitude and this amplitude, if you'll compare, this is more. And then again going back. So again statically stable, because it is having tendency to come back, but again it is displacing more, correct? So this graph means this graph is the graph for statically stable but dynamically not stable. Not stable means neutral or unstable. Make sure this is unstable. This one is dynamically neutral, but this one is, so see this kind of line is coming here, right? Now all the maximum if you touch, so this line is giving you idea, the complete idea about dynamically unstable. Got it? And if like I have shown here, if you have a graph something like this, so your displacement is keep on decreasing and after some time it will touch the 0. So this graph, this is the initial displacement, and after some oscillation displacement is decreasing and achieving 0. So this graph is again statically stable but and dynamically stable also. So this is the only graph. So you know, I hope you will be knowing this is called damping. What is damping? Damping means not dumping. It's not DUMP. It's damping, DAMP. Because one of my students said dumping, so that's why I just for fun. Okay, so damping. So damping is there. So I hope all the graphs are clear. So in next video we are going to discuss other topics. So nature is over. Nature means how to discuss statically stable bodies, dynamically stable bodies and graphs, all are over. Now we'll come to the other portions. Okay, thank you. Watch the next part. And you have to hit the like button. You have to comment your doubt. You have to comment about the video and subscribe the channel. Thank you so much.